Alright, welcome to part 7, and this is a note to self. Don't use dark blue for a sustained period of time. It's difficult to see. Hopefully you guys managed to make it through part 6 without developing some sort of eye strain. Alright, so 42. This is much better to see. And I think the blue is okay, but this is a lot better. Alright, so log base 3 of 6xy. So here we're expanding the log expressions and simplifying. So imagine that this, like, the product property that we were learning on the last part, or refreshing ourselves over on the last part, said that if you had a sum of logs, it could be expressed as a single log where you smushed all of the pieces into a product. So imagine that this stuff is these smushed pieces. And we want to go back to when they all had their own logs. We want to write it like this. Log base 3 of 6 plus log base 3 of x plus log base 3 of y. So again, if you were to think condensing, and you have this stuff here, you would condense these two. If you wanted to do it, just one at a time, where you take this times this, and that is 6x. And then you would take that 6x times y, which would be 6xy. So this is your answer. Alright, moving on to number 42, or 43. This is a typical quotient property. The natural log of 7x over 3. So if you look here, the first thing you should notice is that you've got a quotient. You've got a product in the numerator of that quotient, but you have a quotient. So you need to separate the quotient out first. So the way it works out, it's simpler to think of it this way, in my opinion, than going the other way, and that's that it's a difference of logs, and it's the natural log, in this case, of 7x minus the natural log of 3. So you've got the natural log of 7x minus the natural log of 3. Now this is something to pay close attention to. On this problem, it'll work out fairly simply. However, I'll talk about a situation in which you would need to be very careful with this negative sign. So if you notice, again, just how we had 6xy here, that's a product, 6 times x times y. We have a product here as well, that's 7 times x. This can expand more using a sum of logs. That's what we're going to do. So this expands farther into natural log of 7 plus natural log of x minus natural log of 3. And you're done. That's the finished version of the problem. Now, what I was talking about earlier, with this negative sign, had the x been here instead, right? So this is the answer, just so you all know. But we're going back and looking at a separate problem that's similar. Had the x been in the denominator, then when you split it into the quotient property here, into a difference of two logs, the x would be over here with the 3. And now the problem comes up is, like, when you try to split this up into a sum of logs, there is a minus sign in front here, but this log splits into a sum of logs, the natural log of 3 plus the natural log of x. This minus sign was being applied to this log, and it's still going to be the natural log of 3x turned into this. It's still a negative version of this. So it would be negative natural log of 3 minus natural log of x, so that you distribute the negative. All right, that's something important to point out. All right, I'm not sure if we'll see a problem like that. It looks like we do see one on number 45, but I really just wanted to point that out here. So let's erase this stuff. All right, so now we're back to number 44. Number 44 is the first problem that uses the power property along with another property. So here we've got log of 5x to the third. So the first thing you want to do is separate the product. First and foremost, this is a product. 5 times x to the third. So you want to separate this into a sum of logs. Log of 5 plus log of x to the third. Now, it's not fully expanded until this 3 is moved in front of the log using the power rule. So it would be log of 5 plus 3 log of x. All right? That's it. You're done. Number 45. This will be the last problem on this part, and then we'll move on to sequences and series. Log of the quotient x to the fifth y to the negative 2 power over 2y. Now this one is really tricky. Alright, so the first thing you want to do, and we have not talked about this, this brings up an interesting point, negative exponents. We didn't have any problems over that. I'll probably have to give you some more stuff over this. But negative exponents, I'll come over here and start writing about negative exponents. Negative exponents represent reciprocals. Alright, so if you have got x to the negative 2 power, that represents 1 over x to the second power, where you take the reciprocal of the base. Right now it's x over 1. The reciprocal is 1 over x, and then square that. So when you flip the base, the negative sign essentially goes away. And then it's just to the positive 2 power. So here you've got y to the negative 2 power. That would be 1 over y to the positive 2 power. Now technically speaking, this is 1 over y as a quantity to the second power, where you'd have to distribute the squared into the numerator and the denominator, but when you just have a single thing here, it's just going to end up looking like this because 1 squared is still 1. Alright? So we want to do this first with our negative 2 power here. And the reason is because you can simplify it with this y down here. And it will create fewer, there won't be a product in the numerator. That's important for us. So think of this as we just did, y to the negative 2 is 1 over y squared. So the idea here is to make this y this negative 2 positive, you want to move the base, which is y, down to the denominator. And then you'd have, I'll go ahead and just write this in red, log of x to the fifth over 2y, and then that y to the negative 2 moves down into y to the positive 2. Keep simplifying. Alright, so everything's looking good so far. The y times the y squared, you add the exponents, so 1 plus 2 is 3. Now, as we did here, we separate the quotient into a difference of logs. So let's do that. So here's our quotient. We're going to separate it into a difference of logs, where it's log of the top minus log of the bottom. And I'm actually going to write this down over here. Log of the top. I don't know why I have done that every single time. Log of the top minus log of the bottom. Now, any products need to be turned into separate logs. So here we've got 2 times y to the third. So this is going to be separated. This piece here is going to be separated into log of x to the fifth minus, now the parenthesis here is important for the reason I was talking about earlier on this example problem I erased. Log of 2 plus log of y to the third. Now, any powers can be moved in front of their logs. So these can be moved in front. And you'll have 5 log of x. And then here, You are distributing the negative sign through. So you've got minus log of 2 minus log of y to the third. And now you are done. You can't use the product rule anymore, you can't use the quotient rule anymore, and you can't use the power rule anymore. Wait, I lied. You can, right here, check it out. Wait, why did I write this at times? I don't know. This 3 that I said needs to move in front, it didn't do that. There we go. Now we're done. Excellent. Alright. Again, thank you for joining me. I will catch you on the next video.